All right. What I need you guys to do first, before we get into your notes or anything, I need you to pull a device out. Chromebook or tablet would be preferable. If you don't have that, your phone can work. A Chromebook, tablet, phone if you don't have either of those. It will work okay on your phone. What I need you guys to do after you have your device out and powered up, I need you to go to Canvas and go to today's page on Canvas so that you can click on this link right here. Should open up a page that looks like this. So you want to get your device turned on, powered up, go to Canvas, go to Modules and find today's page under Chapter 5. Should be the very top page in the module for Chapter 5. And there's a link underneath the first bullet point there that will take you to this page. While you guys are working on getting there and doing that, this test, Chapter 5 test, this comes up real quick. This is a very short chapter. Test is next Friday. Test is next Friday, which is the 25th. Unless you are a sophomore or a junior, I will not see you guys the day before the test. That, once again, is going to be our multiple choice practice day. I'll have that stuff on Canvas for you so that you can practice the multiple choice. Going into next week, we'll finish up our very last lesson on Monday. Tuesday and Wednesday, we're going to spend doing FRQ and then taking questions over the test review so that Thursday you can do some multiple choice practice. And then we'll have this Chapter 5 test on the 25th. Yes. The day before the test is PSAT for sophomores and juniors, so it's job shadow or college visit for seniors. Yes, they have all that stuff on your PHS Canvas as far as what activities you can do. All right. If you are not here, I trust that you know how to get here. I shouldn't be going too fast for you at this point. Also, the homework that you grabbed on your way in the door, that's due on Wednesday. And there is a relatively short reading assignment that I would like for you guys to complete to be ready for class tomorrow. It's 9 pages, page 326 to 335 in your book. 326 to 335 in your book is the reading assignment that I would like for you to complete. Homework's due Wednesday. All right, getting into your notes. Page 3 in your notes. If you would flip open to page 3. If you're still waiting on your device, we're not going to use it just yet. I want you guys to take just a few moments to answer these 3 questions. Take a couple of moments to answer these 3 questions. We're going to take about, let's do 3 minutes tops, preferably more like 2 or 3 minutes to answer these 3 questions. Answer these 3 questions to the best of your ability. No right, wrong answers yet. Just get your thinking down on the page. Canvas first. You'll go to modules and you'll find today in chapter 5, and there will be a link on today's page. So you can do the activity with us. All right, so I'm curious. Again, there's no right, wrong answers here. In your own words, what would it mean to be an 80% free throw shooter? Yeah. They miss 20% of the free throw shots that they take. 80% of attempted free throws made it into the basket. Did anybody else have something slightly different? Again, there's no wrong answers here. Yeah, I like both of those so far. Again, this is just in your own words. What does this mean? I had each free throw has an 80% chance of going in. You do not have to copy my answer. Mine is not right. It is just a possible student response, ones that I've gotten before. If Mrs. Bolliton takes 100 shots and she really is an 80% free throw shooter, how many do you expect her to make? 80. Is it guaranteed that she's going to make 80? No, not guaranteed. So I expect her to make 80, but it's not a guaranteed thing. If she takes 100 shots, do you think she's going to have like a hot streak where she makes 10 shots in a row, back to back to back to back to back? Camila says no. Did anybody say yes to that one? Yeah, there's no right or no wrong. This is what do you think will happen. I'm asking you to make a prediction. I'm going to write down the first answer that I got back, though, which was no with a little bit of a question mark on it. If you said yes, there's nothing wrong with that. I'm just simply asking you to make some predictions. All right, we're going to test this out now. And this is where that app comes in. I have a table there, and I'll go back and forth to show you exactly what I'm looking for here. But what I want you guys to do on the app, this line right here is at 80%. We're going to be recording percents on the y-axis. Double check that this is an 80% right here. It says Mrs. Gallus instead of Mrs. Bolliton. Don't worry about that. Should say 80% here. There's a button right here that says shoot. Right underneath it, it says shot statistics. Where it says shoot, I want you to go ahead and click on that. Woohoo! Mine made it. Last period, I missed my first shot. If yours made the first shot, raise your hand for me. If yours missed the first shot, raise your hand. Yep, that's last period, I missed my first shot on this one. Okay, so what I want you to do now, regardless, I want you to record your own data. Mine made the first shot. So what's the percent made then? On mine, it'd be 100. If you missed your first shot, yours would be 0. So mine's at 100. All right, now we're going to go do a second shot. So go ahead and hit the shoot button again. No, I missed my second shot. Yours might have made it. We're going to go back and record that on the page. What would mine be at now? I'd be at 50%. If you made your first and your second shot, you would still be at 100. If you missed your first and second, you'd still be at 0. All right, I want you guys to do this for the third shot, the fourth shot, the fifth shot. And then I want you to take 5 shots in a row. You don't have to record what happens on number 6, number 7, number 8, number 9. But you're going to go all the way up to 10 shots. If you look here on the app, it says shoot. It has shot statistics. It says 1 out of 2, 50% on mine. So it tells me how many shots I've taken and what my percentage is. Because as we start adding more and more shots, that percentage gets more and more difficult to calculate. I would like you guys to fill out the entire table. So record what happens on the first shot, the second shot, third, fourth, fifth. Then I want you to take 5 shots in a row really quickly. Record what happens on the 10th shot. Did you make or miss the 10th one? And then write down what your percentage is. And then do that for 15 and 20, 30, 40, 50, 60, 70, and 80. You got 10 in a row? That's awesome. Really? Mm-hmm. Yeah, fill in the table, and then I want you to copy the graph too after you get out to 80 shots. I do want you guys to add one more, and I know we're going to have to squeeze it in back here, but we were talking about if Mrs. Gallus took 100 shots. So after you do 80, I want you to do 20 in a row quickly and take it out to 100. On your table, you should be recording your data. You need to sketch your graph, which is going to be slightly different than mine. Yes. Oh, that's what my percent was when I made those shots. I was getting it from right here, right there. Did anybody else's graph look kind of like-ish this? Yeah. What do you notice about the graph? As you're just looking at it from where we started and then taking it all the way out to 100, what do you notice? Yeah.
It varies less.
It varies less as it goes on. I like that. So back here, we were unpredictable. Lots of variability. This was in our short run. It's like the first, I don't know, on mine's pretty unpredictable for at least the first 20 shots. It's kind of back and forth and all over the place. But as we move further out on this graph, over here in the long run, it becomes predictable. This is in my long run. Because remember, what we're plotting on this graph is not whether we made or missed the shot. It's what percentage of all the shots taken up to that point had been made or missed. Lots of variability at first. Yours should be hovering somewhere close to this 80% line at the end. Mine's a little above it. Mine ended at 82%, but several times I got right at 80. When you look at what happened, like I hit 80% at 5 shots, I hit 80% at 10 shots. 20 and 30 and 40, I was at 80%. At 80 shots, I was exactly at 80%. But by the time I got to the end, I made 82 out of the 100 shots when I did this. What we call this type of pattern, where there's lots of variability at the beginning, and then it starts to even out and tend towards a certain percent in the long run, we call this the law of large numbers. The law of large numbers says that if I repeat a trial over and over and over and over and over many times, we will begin to approach the true probability. The more trials, the closer we are going to approach the true probability. Did anybody get exactly 80 shots when they got up to 100? Wow. You got exactly 80, exactly 80, exactly 80? That's awesome. So on question 7 for the 3 of you guys, you're going to put that you got exactly 80. I did not get exactly 80. So on my number 7, I'm going to say no. You got 81, so you'd still say no because you didn't get exactly 80. I got really close to it. I got 82. Did anybody else get like within 2, somewhere between 78 and 82 at the end? A lot more hands going up. Some people are off from that. That's okay. In my group of 100 shots, I didn't get exactly 80. If you did get exactly 80, you would say yes here. But the second part of the sentence still holds true. Every random sample of 100 shots is a little bit different. We've got some sampling variability going on in the room here. In the 100 shots that you took, did you get any streaks of 10 or more makes in a row? Yeah, I had a streak of 10 for sure. In fact, if I go back and look at my graph, I think, like right at the end back here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 19 makes in a row there. Did most people get at least 10 makes in a row? Yeah. This is actually a really common event. When we're looking at something like this, where the true probability is 80%, we want to know whether it's a make or a miss. 92.8% of the time, you're going to get a streak of 10 in a row. So question number 1 was getting you to begin thinking about what an 80% free throw shooter means. Based on the results that we just saw here, what does a probability of 80% mean? In the short run, were we at 80% and stay really close to it at the beginning? No, when I go back and I look at my graph, at the beginning it was above, below, above, below. It kind of bounced back and forth. In order to see it begin to flatten out, I had to do this many times over. After many, many, many free throws, the percent of makes will approach 80%. Probability is the long run relative frequency. All right, when you are done getting this into your notes, go ahead and flip over to page 4 for me. Oh, that's interesting. Yours was above for quite a bit of the time. That's a really interesting graph. Probability, long run, relative frequency. It's always going to be a number between 0 and 1. And then it has this word inclusive. Does anybody know what I mean by inclusive? Yeah, it's going to include, like 0 is a possible value for our probability. 1 is a possible value for our probability, and everything in between. A lot of times people will refer to probabilities instead of in decimal form, they'll refer to them as percents. In that case, a probability of 1 would be the same as what percent? 100%. A probability of 0 would be 0%. The short run is always going to be unpredictable. But the long run is predictable. The more trials we add, the closer to the true probability we get. That's what our law of large numbers says. When we simulate our probabilities, we get closer and closer to the true probability as the number of trials increases. We can see this happen like with pregnancies and births and the at least assigned at birth gender. What's the probability of having a boy? 50%. Probability of a girl is 50%. Are there any families that have like 5 girls and no boys? Yeah, there can be a streak like that. The more trials we add, when we start looking at all the pregnancies over like the last 100 years, we're going to come up with more like a 50-50. But when you look at just isolated cases, like one family, it's not necessarily going to be 50-50 there in that short run. All right, let's hop down to the check your understanding. This first one right here, we have 6 probabilities over here: 0, 0.001, 0.3, 0.6, 0.99, and 1. I want you to complete this probability column. Look over here for the explanation and decide which one of these numbers best fits as the probability. Take about, 30 seconds. Don't spend too long. All right, what do we think? An impossible event. It can never occur. 0. A certain event or a guaranteed event. 1. Very unlikely, but it occurs once in a while. 0.001, yes. This outcome will occur more often than not, but it doesn't occur almost every time. 0.6, yes. I want to get some examples written down. Put down your own example. I'm going to give you guys about 1.5 minutes, 2 minutes. I want you to write down your own example of something that's impossible, something that's guaranteed to happen every single time, something that's very rare but not impossible, and something that happens more often than it doesn't. So take about, like I said, take about 1.5 minutes, 2 minutes. What's something that's impossible? Be an impossible event. 3 Friday the 13th. What's another event that's impossible? It rains cats. That's impossible. That when I add 2 plus 2, I get 7. That's impossible. I'm not saying that no child would ever give it as an answer, but it is not true. The example that I came up with, if I've got just a normal 6-sided die, can I roll a 7? Not with just one roll. So that was my example. Anything that's impossible, you can write down here. This outcome is certain. It is guaranteed. For our next one. What's an example of an event that is guaranteed? The Earth spins. What's another guaranteed event? Monday comes every week. Every week's got a Monday in it. What's another certain event, another guaranteed event? Christmas is on December 25th. That is a guaranteed event. If I've got just a regular standard deck of playing cards, 52 cards, no tricks from me, when you pull a card out of that deck, you're going to get either a red card or a black card. That would be a guaranteed event. So any of those would work as guaranteed or certain events. This outcome is very unlikely, but it will occur once in a while in a long sequence of trials. What's something that would be really rare but not impossible? Yes. Winning the lottery. That's a great one. Winning the lottery. Very rare but not impossible. Yes.
Pike's varsity football team goes to state.
Pike's varsity football team goes to state. Yes. The person that I got this activity from, they were like, our track team beats the rival school. It's not impossible, but it's not very likely. For my example, what I put up here, I don't sports ball really. I'm not so much with the sports ball. If I hit a home run, that would be highly unlikely. Not impossible, but highly unlikely. What about something that would get a probability of 0.6? It happens more often than it doesn't, and it doesn't happen all the time. What'd you say? Slip on ice. What else? What would be another event that happens more often than it doesn't, but it doesn't happen all the time? Yeah.
McDonald's ice cream machine doesn't work.
There we go. McDonald's ice cream machine doesn't work. You can make memes about it. It's a sunny day in Indianapolis. Happens more often than it doesn't, but it doesn't happen almost every day. Any of those would be great answers. I want you to have an example down that you can relate back to. Don't just copy mine. All right. Let's look down at question number 2. You guys ever seen even just a clip of Wheel of Fortune? So you guys are familiar with like the gist of the game. You spin this gigantic wheel that's been divided up into sections that lands on either bankrupt or a dollar amount. You make a guess about what letters you think are in the word or phrase.
Buy a vowel.
You buy a vowel. In the Wheel of Fortune, 1 out of every 9 of those sections, has bankrupt. So on any given spin, you have a 1/9 or an 11.1% probability of getting a bankrupt. How would we interpret that? What does it mean to have an 11.1% probability of spinning a bankrupt? So if we only spin it 9 times, are we guaranteed to get a bankrupt? No. After what?
After many spins.
After many spins, about 11.1% of the time, we're going to land on bankrupt. This is our long run probability here. After many spins on the Wheel of Fortune, the percent of time spinning bankrupt approaches 11.1%. All right, so scenario time. They've all been taking turns spinning the wheel. The next contestant has been watching, and the 9 times before that it's been spun, it has not landed on bankrupt yet. The next contestant worries that he is more likely to land on bankrupt now because bankrupt is due. Why is that wrong? The probability doesn't change. The probability is still going to be 11.1%, 1/9. Probability is unpredictable in the short run. Even for an 80% free throw shooter, you weren't guaranteed to make your first shot. You weren't guaranteed to make your first 2 shots. Out of the first 5 shots, you might have made 2 of them and missed 3 of them. Streaks are also really common. So a streak of not landing on bankrupt over and over and over and over, it's possible that this continues for another 9 more spins before we see a bankrupt show up. The idea that bankrupt is due, that's like, I feel it in my gut too. I've been teaching this for a while. You feel like it's going to be coming. It hasn't happened yet. It's going to be coming. But that idea that something is coming due just because it hasn't happened yet, that is not a right thinking idea there. We're actually seeing stuff like this happen with different storms. You guys ever heard of like a 100-year flood? A 100-year flood means that on average, in 100 years, you will have a flood of that level one time. Is it possible that you get a 100-year flood and the very next year you get another 100-year flood? Yes, it's unpredictable in the short term. Is it possible you go 300 years and you don't have a flood of that level? Yes. Probability is unpredictable in the short run.